Okay, so our first one up here is just a ratio and proportion problem. Actually, it's a rate and proportion problem. We have Pat who drives 270 miles in 6 hours. It doesn't matter which one we put on top, but typically we put miles on top of hours. So we end up with a rate here of 270 miles in 6 hours. Now, if we were just looking for a rate, we would divide that out by 6 and get a unit rate. But since we're actually looking to apply it to another situation, we can just put it in a proportion. How far can Pat drive in 10 hours? Was the hours going to go on top or bottom over here? On bottom, because we've got hours on bottom on the other side. Remember, we have to maintain those relationships. The units have to stay the same. So now we cross multiply and divide, and we get 450 miles. Good. So in 10 hours, Pat will drive 450 miles. This next one down here, reducing an algebraic fraction. Remember, the way we did it was we pull out the number and we just reduce the number. 27 and 36 can both be divided by what? 9. Very good. 27 divided by 9 is 3. And 36 divided by 9 is 4. So this is 3/4 here. And then we have to reduce the variables. We'll do each one at a time. So with the x's, remember the first thing we have to do is decide, is it going to be on top or bottom? It's going to be on top. And then what power? 4. It's on top because the larger power was on top, and then it's 8 minus 4 is 4. For the y, is it going to be on top or bottom? Bottom. The bigger power is the 4, it's on bottom. I think if this is a y to the 1, what's the power going to be? It'll be 3. 4 minus 1 is 3. And then z, top or bottom? Bottom with a power of 1 or just z. So there it is. We have reduced that fraction. Okay, that's going to take us to our next step, where we're going to start combining fractions, multiplying fractions. So if I have 2/3 times 1/4. If you recall, when we multiply numbers, actually multiply or divide numbers, we don't need the same name. So for fractions, that means denominators. We do not need a common denominator. And second, we're going to also combine the names. So we'll multiply the names. We don't need the same name. So let's go ahead and do that. We're going to combine our counts like we always do. We're multiplying, so we're going to combine them with multiplication. So 2 times 1 is 2. And then we also combine the names. 3 times 4 is 12. Now we look at that 2 over 12, what can we still do? Both of those can still be divided by 2. There you go. 2 divided by 2 is 1, and 12 divided by 2 is 6. So you get 1/6. Now some of you might be looking at this original problem, the 2/3 times 1/4, and asking, why didn't he cross cancel, or what's sometimes called cross multiplying? Others might not be totally sure what that is. Well, if we look at this, the top is going to become 2 times 1. And the bottom is going to become 3 times 4. And as we look at that, we see both the 2 and the 4 can be divided by 2. So what we can do is, before we multiply, we can cross cancel or reduce by common factors before we multiply. So the 2 and 4 both divide by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. And now when we multiply, we have 1 times 1 is 1, and 3 times 2 is 6. So we reduced before we multiplied. Now in a problem like this one, it's about the same amount of work either way to cross cancel first, or to just multiply it out and reduce. But we can run into problems like this. 24 25ths times 35 36. We could go ahead and multiply that out. I mean, 24 times 35 is what, 840? And 25 times 36 is 900. And then you could reduce that. Now, of course, you'd probably look at it first and you'd see the zeros. And you'd say, okay, both of them can be divided by 10, so we'll do that. So this is 84 over 90. Then you might see that both of them can still be divided by what? They're even, so we can divide by 2. That is 42 over 45. Are we done there? No. What can we still divide by? There you go. 4 plus 2 is 6, 4 plus 5 is 9, so both of those can be divided by 3. So that's 14 over 15. If you're lucky enough, you might have seen that both of those can be divided by 60. However, with what we learned up here with our cross-canceling or cross-multiplying, whatever term you learn to call it, we can reduce before we start. Now, I'm going to always use the term cross-canceling. I realize some of you called it cross-multiplying. The reason I use cross-multiplying is there's actually another process out there that's called, or cross-canceling, I should say. There's another process out there that's called cross-multiplying. I don't want people to confuse the two. But anyway, here, 24 and 36 can both be divided by what? Bless you. They can both be divided by 4 and 6. They can also be divided by 12. If you saw the 6, you divide by 6, you divide by 2 again. 24 divided by 12 is 2. 36 divided by 12 is 3. How about 25 and 35? Those can both be divided by what? 5. 35 divided by 5? 7. 25 divided by 5? 5. And now we can multiply. 2 times 7 is 14, and 5 times 3 is 15. To me, this is a lot less work if we can reduce before we multiply. Now, I realize a lot of you out there have fraction calculators. The one I recommended to you is a fraction calculator. And if you're using that fraction calculator, you can enter these fractions in. Most of them have an ABC key that looks like that. If you're going to enter in, let's do it 80 over 25. You would type in 80 ABC 25. And it's going to spit out 3 1/5. So not only can you enter the fractions in the calculator, but it will automatically not only reduce it, but split it into a mixed number for you. So if you wanted to do these multiplications, if I have, let's say we have 8/9 times 3/20, you could enter those fractions into your calculator. Now we're going to do this by hand. What can we reduce here? Before we multiply, what can we cross cancel? 9 and 3 can both be divided by what? 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. Good. 8 and 20, can that be reduced?
4.
By 4. Good. So 8 divided by 4 is 2, and 20 divided by 4 is 5. So 2 times 1 is 2. 3 times 5 is 15. 2 15. Now again, you could have entered that in your calculator. 8 ABC 9 times 3 ABC 20. Hit equals, and it will spit out that 2/15. However, we're going to also look at problems that look something like this. We're going to throw the variables in there. This one you obviously can't do on your calculator because your calculators don't do variables. Not unless you have a really expensive one. To work with this, I would recommend just like we did when we reduced a fraction, we pull out the numerical part of the fractions. Now, is there anything we can cross cancel there in the numbers? Yep. What can we do? Perfect. So we can cancel out 7 and 14 both divided by 7. 7 divided by 7 is 1, and 14 divided by 7 is 2. Good. Anything else we can cancel out? 20 and 15 both divide by 5. What is 15 divided by 5? 3 and 20 divided by 5? 4. Good. So now we'll multiply those out. 1 times 3 is 3. 4 times 2? 8. So the numerical part of our answer up here is 3/8. Now to get the variable part, I'm just going to pull out the variables. I'm going to go ahead and multiply. Well, x squared times y squared is just x squared y squared. Y to the 4th times x is just x, y to the 4th. I did put them in alphabetical order just because it's easier to have them in that order. And now it's just a matter of reducing again. X squared over x. Is it going to go, x going to go on top or bottom? It goes on top, and it'll have a power of 1, or just x. So this is x to the 1. 2 minus 1 is 1. Y squared over y to the 4th. Is y going to end up on top or bottom? Bottom. And a power of 2. Good. The larger power, y to the 4th, was on bottom, and 4 minus 2 is 2. So that's our answer right there. 3x over 8y squared. That'll be nice. So 12x to the 3rd over 25 y to the 5th times 35 y to the 8th over that would go 24x. We'll leave it like that. So again, we're going to do the same thing. We're going to pull out the numbers. 12 over 25 times 35 over 24. What can we reduce there? 12 and 24 can both divide by 12. 12 divided by 12 is 1, and 24 divided by 12, 2. Anything else can be reduced? 25 and 35 can both divide by 5. Good. 35 divided by 5? 7. And 25 divided by 5 is 5. Good. So now we multiply. What's 1 times 7? 7. 5 times 2 is 10. So the number part of our answer is 7 over 10. So now I have to look at the variables. I'm going to pull those out separate here. I've got x to the 3rd over y to the 5th, y to the 8th over x, and I'm going to multiply them out. What will I end up with on top here? X 3rd, y to the 8th, yep, and on bottom? Bless you. I'm going to change them, yes, but x first, x, y to the 5th. So now for my answer, all I'm doing is reducing the fraction here for the variables. Where's x going to end up, top or bottom? Top with a power of 2. Good. The larger power is the 3, so it's on top. Just think of that as a 1. 3 minus 1 is 2. Is the y going to end up on top or bottom? Top, because the 8's the bigger power. And it's going to end up with a power of 3, because 8 minus 5 is 3. So there we go. 7x squared y to the 3rd over 10. So here, you guys tell me where to start. Take out the numbers. 12 over 7, okay. 21 over 16. Okay. Okay. Okay, perfect. Perfect. 3 times 3 is 9, and 4 times 1 is 4. Okay, so the number part is 9 over 4. And yeah, we're going to take out the variables, so what's going to go here for the variables? Nope, let's just put them up here. Okay. There we go. Y to the 5th over x to the 6th. Perfect. So all we're doing is just taking out the variable portions here without the numbers on it. Then, of course, we're going to combine those to get what?
X squared, y to the 5th, and then x to the 6th.
Perfect. So we just multiply them out. We put them in alphabetical order. And now we're going to reduce. So x ends up where? Bottom, power of 4. 6 minus 2 is 4. Y ends up on top, power of 4. Good. 5 minus 1 is 4. That is as far as we can go. A lot of people are tempted to look at that and split it into 2 and 1y to the 4th over 4x to the 4th. Remember, we cannot do that. When we have algebraic fractions, we can never turn them into that appearance of a mixed number because we don't know the value of those variables. This may not be an improper fraction. X might be 7 and y might be 2, and the numerator would be smaller than the denominator. So we don't know, so we cannot split that into an improper fraction. Okay, I'm going to have you try one of these on your own in your notes. Give that one a shot in your notes. We'll give you a couple minutes to get it done. You guys need another minute, or are you good to go? Let's take a look. So where do we start? Take out the numbers. Good. Okay, and with them, what can we do?
21 divided by 7.
So reduce the 7.
32 divided by 4 is 8, and then 20 divided by 4 is 5.
Perfect, and divide out the 4s. Okay, so 3 times 5, 15, 8 times 1, 8, so we make that 1 and 7/8? No. Never make it into a mixed number. Always keep it as an improper. So 15 over 8 is the numerical part of our answer. Then what? Okay, so what goes in the first one here? Yep, x to the 5th over y to the 7th. And then the next one? Okay. So I threw a little bit of a curveball in there on you. Now we have to multiply these out. X squared, y squared is x to the 7th, and then y to the 4th. On bottom, we've got y to the 7th, z squared. So in our answer, there's nothing to combine with the x, so that x to the 7th just stays on top. What about the y?
It goes on the bottom.
Perfect. The larger power is on bottom, so it goes on bottom, and 7 minus 4 is 3, so it's y to the 3rd. And finally, z squared. It's right there. So 15x to the 7th over 8y to the 3rd z squared. How many of you got that? Any questions on those? Okay. Well, our next step, before we get too far, I want to do one like this. How would you do a whole number times a fraction? Put a 1 under it. Good. So now it is 8 times 2 is 16, 1 times 3 is 3. And now, of course, that can be reduced. There are no variables in that, so that can be reduced to a mixed number. 3 goes into 16 how many times? 5 with 1 left over, so 5 and 1/3. We've said before that multiplication and division follow the same rules. When we multiplied, we just multiplied straight across. When we divide, can we divide straight across? Can I do 12 divided by 4 is 3, and 25 divided by 5 is 5? Does that work? Is that the right answer? It actually is. Does that work every time? It actually does. So why don't we do it that way? Well, we don't do it that way because we run into problems like this. 3 divided by 2 is 1.5, and 4 divided by 3 is 1.33333. It doesn't come out very even, does it? How have you been taught to divide fractions? Perfect. The first one never changes. 3/4 is going to stay 3/4. It's the second one that we're dividing by. The division symbol, the operator, works on the second fraction. So it becomes multiplication by 3/2. Do you remember what we called this when we went 2/3 and changed it to 3/2? Reciprocal is the word we used. Basically, it's just flipping it over. So we take the reciprocal, instead of dividing by 2/3, we multiply by its reciprocal, which is 3/2. So 3 times 3 is 9. 4 times 2 is 8, and that does reduce to 1 1/8. Believe it or not, this process of multiplying by a reciprocal comes from what we just did up here. Now, you don't have to write this down because I'm never going to test you on this, but once upon a time, 3/4 divided by 2/3, they would have looked at it like this. First of all, 2/3 is reduced as far as it can go, right? Can't reduce it anymore. That'd be the first thing to do, is make sure that fraction is reduced. Then we're going to take numerator times denominator. What is 2 times 3? 6. We're going to use that 6 to rename our first fraction. By rename, I mean this. We're going to multiply by 6 on top and bottom. What's 3 times 6? 18, and 4 times 6? 24. And then we'll divide it. So 18 24ths and 3/4 are the same value, right? We just change its appearance. Then if we divide by 2/3, what's 18 divided by 2? 9. And 24 divided by 3 is 8. 9/8, or 1 1/8. That's the answer we got over here. How on earth did we get to multiplying by the reciprocal to all this mess over here? Now, it's not as big of a leap as you would think. At some point, someone was looking at this and said, hey, we make this 3/4 divided by 2/3. We do 3/4 times 6/6, and then divide by 2/3. And what happened is they looked at it and said, hey, if I fudge my order of operations a little bit, and I do this part first. If I do 6/6 divided by 2/3. Well, 6 divided by 2 is 3. 6 divided by 3 is 2. What I always get there is just this fraction flipped over. And then I'm left with multiplication. So what they did is they just defined that term reciprocal and said, okay, when we divide by a fraction, we're just going to multiply by the reciprocal. Multiplying by the reciprocal is nothing more than doing this process up here, only skipping about 3 steps and just getting right to the end of it. Now, like I said, I'm not going to change the way you guys divide fractions. I expect you're still going to divide them the same way you always have. But sometimes it's neat to see where stuff comes from. So anyway, when we go now to divide our fractions, we are going to just go ahead and divide by the, or multiply by the reciprocal. If I have 13/20 divided by 5/16. So what am I going to do with that? Does the 13/20 change? No, the first number does not ever change. Like when we were doing subtraction, if we had like a -8 minus 7, the first number never changed. Let's say -8. It was the second number that dealt with the subtraction. That became plus a -7. Same here. It's the number that comes after the operation that is affected by the operation. So then we've got 13/20. What are we going to do to it? Times the reciprocal. So 5/16 becomes 16/5. Now at this point, this is multiplication, which means we can do everything with it that we could do with multiplication, including cross-canceling. I can divide out the 20 and the 16, both divide by 4. 20 divided by 4 is 5. 16 divided by 4 is 4. And I can go ahead and divide out. 13 times 4 is 52. 5 times 5 is 25. I can convert that now. There's no variables here, so I can convert this into a mixed number. 25 goes into 52 twice. 2 times 25 is 50. And there's 2 left over. So that is 2 and 2/25. These are my results. Any questions? One thing I want to bring up here before I move on, by the way. When we divide, I thought it made things smaller. If I have 28 divided by 7, I get 4. Dividing makes things smaller usually. Why here was I able to take two things that are smaller than 1 and get a number that's over 2? If you remember, we talked about this on the second day. Division is repeated subtraction. 5/16 is smaller than 13/20, so I can subtract it. In fact, I can subtract it twice with a little bit left over. So it's not the operation that determines whether we get something bigger or smaller, it's what we're dividing by. So the fact that we're dividing by something smaller than what we're starting with means we are going to get a number bigger than 1. So if I divide, I'll have you try this one in your notes. 14/15 divided by 7/20. Go ahead and try that one quick. Okay, see how you did. What did I do wrong when I set this up here? Yeah, I took the first fraction, I did its reciprocal. That is not how we do it. The first fraction never, ever changes. That will be 14/15, period. It's always the fraction after the operation that is affected by the operation. So dividing by 7/20 is times 20/7. Now what can we do? Okay, which one's going to cross cancel?
15 and then 20 divided by 5 is 4.
Perfect. 15 and 20 both divided by 5 to give me 3 and 4. And what else?
And then 14 divided by 7 is 2. And 7 divided by 7 is 1.
Perfect. 14 and 7 both divided by 7 to give me 2 and 1. And now Just multiply across. 2 times 4, 8. And 3 times 1 is 3. And of course, that is 2 and 2/3. Again, I was dividing by something smaller than what I started with. 14/15 is almost 1. So I'm expecting to get something larger than what I started with. Larger than 1 in this case. So looking at one like this, we're throwing in the variables again. But because we change our division into multiplying by reciprocal, this is really nothing new to us. This is exactly like doing our multiplication. The only difference is we have to start out with an extra step, which is to take the reciprocal of that second fraction. So the first one never changes. The 21x over 25y squared becomes 25y squared over 21x. We just flip it over, take the reciprocal. Then what can we do? Well, now just like our multiplication, I would pull out the numbers. What can I reduce there? Both 7 and 21 divide by 7. Give me 1 and 3. And both 10 and 25 divide by 5 to give me 2 and 5. 1 times 5 is 5, and 2 times 3 is 6. So up here in my answer, the numerical portion is 5 over 6. And now again, just like multiplication, I'm going to pull out the fractions. So in the first part, I got x to the 5th over y to the 3rd. Here I've got x squared or y squared over x. So that's x to the 5th y squared over xy to the 3rd. So is x going to end up top or bottom? Top. Power of 4. Good. 5 minus 1 is 4. Is the y going to end up on top or bottom? Bottom with a power of 1, or just y. 3 minus 2 is 1. So 5x to the 4th over 6y. We might have 20x to the 8th over 9 divided by 12 over 12x to the 5th over 25. You guys tell me what to do. Okay. Perfect. We take the reciprocal of the second one. The first one does not change. Then what? Take out the numbers. So we got 20 over 9 and 25 over 12. And then perfect. The 20 and the 12 both divided by 4 to give me 5 and 3. That's it for reducing, it looks like. 5 times 25 is 125, and 9 times 3, 27. So I'd make that 4 and 17 27ths. Say no. No. Because there's variables involved, we cannot do that. This is going to stay 125 over 27. Then what? If I pull up my variables, it looks something like that. There is no variable in the denominator of the first one. There is no variable in the numerator of the second one. So that ends up being just x to the 8th over x to the 5th. Which means x is going to go where in my answer? On top with a power of 3. Very good. So 125x to the 3rd over 27. And again, I can't stress enough, do not try to change that into a mixed number. It stays 125x to the 3rd over 27. A lot of people look at this and they want to try to cross cancel the 20 and the 25. Why can't we do that? Nope, not because of variable. It's because it's division. We can only cross cancel when it's multiplication. So we have to wait till we do the reciprocal of that second fraction. Once we're here, now we can cross cancel. That's where we pull out the numbers and cross cancel what we can down here. I'm going to have you guys try one in your notes. Give that one a shot. 8x to the 7th over 15y divided by 5x to the 3rd over 9y squared. Let's see how you did. So first thing we got to do is we've got to take the reciprocal. So the first number doesn't change, first fraction. This becomes times 9y squared over 5x to the 3rd. Then what? Okay. I like to pull out the numbers just so I don't have the variables in the way, but yeah, you got the right idea. 15 can be reduced by 3 to give me 5, and of course the 9 has to be reduced by 3 to give me 3. Anything else can be reduced? Nope, that's it so far. So we multiply that out. 8 times 3 is 24, and 5 times 5 is 25. So up here in the numbers, we've got 24 over 25. Then what to do for the variables? Technically, you don't really have to multiply them out. A lot of times you can just see in the problem. But I'm going to multiply them out. So where does the x end up? Top power of 4. Y ends up top power of 1, or just y, right? 2 minus 1. I know what you meant. Okay. So now that we've done the multiplication and division, just like before, I want to look at what happens when we have something like this. 9 divided by 3/4. Just like with multiplication, we've got to make this whole number into a fraction. We'll make it 9 over 1. Then what? Take the reciprocal. So the 9 over 1 stays. It's going to be times 4 over 3. And of course, we can reduce, we can cross cancel the 9 and 3 to give us 1 and 3. Both divided by 3. 3 times 4 is 12. 1 times 1 is 1. So that is just 12 for that one. A little bit trickier is if we have a fraction being divided by a whole number. Like let's say we have 8 divided by 4/5. Oops. I meant that the other way, but that's okay. We'll do this example. So this is 8 over 1. Yep. 8 over 1 then times 5 over 4. We'll cancel that out. 1 and 2 gives us 10 over 1 or 10. Okay, now actually to the example I was looking for. Let's say we have 2/3 divided by 6. What do we have to do? 6 over 1. 2/3 times 1 over 6. Good. And then cross cancel. 2 and 6 both divide by 2. So they're going to be 1 and 3. 1 times 1 is 1. 3 times 3 is 9. So that's 1/9. Any questions? Okay. Now we talked briefly last week about least common multiples. And we tied it in with our factoring. So for example, if we have 12x to the third, we would factor out the number portion. The 12 factors like maybe 4 times 3. The 3 is prime. 4 is 2 times 2. So the 12 is 2 times 2 times 3. Remember, we like to try to put them in order from smallest to largest. And of course, x to the third is just x times x times x. For least common multiples, we have a pair of numbers, and we're trying to find the smallest number that both go into, that both will divide into. So let's do the 12 and 12x to the third. And let's say the other one we want to look at is 15x to the fourth. So let's factor the 15. Well, 15 factors into what? 3 times 5, and that's it. So it's going to be 3 times 5, and then of course x to the fourth is 4 x's multiplied together. Now that we have it factored that way, when we did greatest common factor, of course, we took the ones that were the same. When we're doing least common multiple, we're going the other direction. We're looking at the ones that are different. But sometimes it's easier to pick out the ones that are different if we pick out the ones that are the same first. So I have a 3 in each of them. I have an x in each. I have another x, and I have another x. So those are the ones that are the same. And once we've picked those out, it's really easy to see which ones are different. To make a least common multiple, I have to have all the factors the same. So this top one has 2 2's in it, the bottom one does not. So I need to multiply 2 2's by the bottom one. Now, those factors are in common. Does that make sense? You see what I did? Just took the factors that one had that the other didn't, and I put them into the other one. Well, the number is changing, but we're trying to find that least common multiple. So now the bottom one has a 5 and an x, and the top one does not. So we're going to multiply that by 5 into x. So now those are the same. So yeah, this is no longer a 12x to the third, and this is no longer a 15x to the fourth. Hopefully they both are the same number now. They better be, because we've got the same factors. So 2 times 2 times 3 is 12, x to the third, times 5 is 60, times another x is x to the fourth. So here we've got 3 times 5 is 15, x to the fourth, times 2 is 30, x to the fourth, times another 2 is 60, x to the fourth. So we factor them down, we adjust the factors, then we multiply them back out. 60x to the fourth is the least common multiple. From now on, I'm just going to write it as LCM of 15x to the third, or 12x to the third and 15x to the fourth. Bless you. Now to start out with, we're not going to be looking at variables like that. We're just going to be looking at numbers. So let's say I give you 12 and 18, and I want the least common multiple. So I'm going to factor my 12. I already factored 12 up above. 2 times 2 times 3. 18 if I factor it. What's any number that goes into 18? 9. What's left if I divide out the 9? 2. Okay, how about 9? 3 times 3. And those are prime as well. So what we have here is 2 times 3 times 3. So again, I look at what they have in common. They have a 2 in common. They have a 3 in common. And then I look at what is left over. What's left over in the top number here? A 2. So the bottom has to have a 2 multiplied into it. What's left over in the bottom? The 3. So the top number needs a 3 multiplied into it. So now both of them have exactly the same factors. Because this is just 12 times 3 is 36. This is just 18 times 2 is 36. So 36 is the least common multiple for those numbers. Now, many of you have done this enough that you can look at numbers and find that least common multiple. And I'm guessing many of you have guessed that the next step we're going to be looking at adding and subtracting fractions, finding least common denominators, which is just a least common multiple. It is our break time though, so let's go ahead and take 10 minutes. We'll start back up at 9:30.